I picked up this ICS Hera Arms CQR earlier this season, and I'm turning it into a reliable primary. Now it's getting a Gate Titan 2 Mosfet upgrade. I've already posted a video on the lower gearbox upgrades, including T238 spiral 13-1 gear set and motor. To shorten this video, I'm going to skip over a full description of the teardown steps for this rifle, and we'll jump straight into the Titan 2 install by starting off with a clean and empty gearbox. If you want a Mosfet that does it all, then this is it, the Gate Titan 2 Bluetooth version. If you found yourself here and you still don't know what a Mosfet is, then in a basic sense, at least for airsoft rifles, it's essentially a trigger bypass, allowing for the full power of your battery to go directly to the motor instead of through your trigger contacts first, which is how a stock AEG would operate. In the Mosfet box, you get a Titan 2 patch, a basic information booklet, which actually doesn't contain installation instructions anymore as it's all online, and accessories including some stickers, DNS connectors, motor connectors, mounting screws, selector plate stickers, and of course you get the rear wired V2 Gate Titan 2 Mosfet. The Titan 2 is so much more than just a basic Mosfet though, with complete electronic control of the trigger, motor, and fire selection mode. If you followed along with Gate, you'll also know that they dropped the tiered app access, and now they offer these Mosfets out of the box with expert tier access, which grants full access to all the Mosfet's features and everything it's capable of. Some of the upgrades I've been most fond of since the original Gate Titan are the built-in Bluetooth for easier access and app control, and the tons of features they've loaded up into the app itself. This Mosfet also works for both AEG and HPA engines. Let's continue to dive into this build with a Gate Titan 2 Mosfet install. First, just straighten out the wires a bit so they're not super coiled up. We want to start off by gently and loosely test fitting the lower Mosfet board into the lower half of the gearbox, and check all around the board for clearances and to confirm if any grinding of the gearbox is required to get a flat, smooth fit. Next, gently hold the Mosfet in place and look at the back of the gearbox to make sure the selector centers or any metallic components of the Mosfet board won't contact the rear of the gearbox edges. Then I like to check the mounting hole for clearance. Make sure the board's well seated and near flush. It may stick off the gearbox shell a little bit, but it shouldn't be excessive. Just make sure that later on that your gears can spin freely. With the loose fit confirmed, we can set the Mosfet into place and roughly shape and route the wires. Black wires run down the near side, and the red wires run down the rear side of the gearbox across the motor opening. Next, we should mount the lower Mosfet into the gearbox. Gate gives you a few screws that you can try, and I just check by trial and error. Don't force the screw in, and don't try to do it down too tight or you can damage the board. When you mount the Mosfet, make sure the insulation washer or the plastic washer is placed so that it's the component touching the Mosfet board directly. The metal washer should not contact the board, and it can be used on top of the insulation washer to help fur out the screw length so it doesn't stick out too far on the back side of the Mosfet board. You don't always have to use this metal washer. As you secure the Mosfet in place, make sure you have an even distance around the sector gear bearing or bushing. Flip the gearbox over once the Mosfet is mounted, and check to make sure that the mounting screw doesn't project out past the rear face of the gearbox shell. If it does, you can grind the screw down, or you can add another one of those steel washers as a filler. Double check that the mounting position doesn't have the selector sensors covered by the rear of the gearbox shell, and double check that there's still no contact between the Mosfet's metallic components and the gearbox shell. Now with the Mosfet board firmly in place, you can use a wide head, non-pointy screwdriver or similar type of tool to press the wires in and shape them. This new ICS split gearbox has an awesome perk that I haven't seen before, which is this wire routing channel that allows the wires to run clean and clear under the motor pinion gear. This is an amazing innovation, and it makes this part of the job so much easier. Often I epoxy my wires down below the motor, just because I caught once before where the wire was snipped, which can easily occur if the wire sticks up at all and you push your motor in, or if they get clipped while firing. The goal with wire routing is to ensure there are no points where the wires can get caught by the motor pinion gear, and also to make sure wires won't get pinched when you close your gearbox shell halves. At any stress points, like sharp kinks or bends, you could sleeve over additional heat shrink to help protect the wire insulation, but you'll find that Gate has already included this at the rear end where the wires pop out the back of the gearbox shell. Next, gently test fit the second half of the Mosfet onto the opposite gearbox shell face. Confirm clearances and any need for grinding. Some gearbox shells may require grinding on this half to ensure Mosfet fitment. At least this has been my experience with 3 of 3 Titan Mosfets I've installed. For this particular installation, part of the gearbox protrusions pressed into the top of the Mosfet, and I need to grind it out to get the gearbox to close without the Mosfet being crushed. To mark out the area that I needed grinding, I just simply laid the top gearbox shell half on the lower and used white paint pen to mark out the length and depth needed for removal. I took this to the shop and used a metal file to grind down the gearbox protrusion. The first time you close the gearbox shell, just make sure it's the Mosfet installed with both halves, and gently close with finger pressure only to see if there's further modifications required to the gearbox shell. Have a look around all the edges with the shell gently pressed closed, and if there's a large gap showing, it may indicate you need to grind gearbox shell further for clearance. Check all around the seam, and with gentle pressure, you should be able to get it closed up. Sometimes the wiring will need to be conformed a little more to the channels, as it can get in the way of closing the gearbox shell smoothly. I'll also be installing a Gate Nova adjustable trigger with this build. This trigger, combined with the tuning features of the Gate Titan Mosfet app, allow nearly endless sensitivity adjustments and control on trigger range. I personally like to have a short trigger pull with limited over travel. This trigger has 2 adjustment screws, one for over travel and one for trigger start position, which effectively allows you to fully tune your trigger sensitivity. I start by backing these adjustment screws off before installing, just to make sure they don't get in the way. First, test fit the trigger without the spring to ensure it has a free movement range. Ideally, you shouldn't test trigger motion with the gearbox open, as it can be a tad wobbly, so be sure to be very careful and do this at your own risk. On the top half of the Gate Titan, you'll see 5 optical sensors, which are the sensors that detect the trigger movement and position. Next, we can put the second half of the board in and close the gearbox shell, still with no trigger spring. We want to first fully test the trigger for range of motion and conflict potential. With this ICS split gearbox, it's super easy to look inside and watch the trigger move. Once you are satisfied with trigger clearance, you can go ahead and test one more time with the trigger spring in. Once you've confirmed that the trigger is all clear and functioning as it should, you can adjust your pre-travel and over-travel adjustment screws. Just use the provided Allen keys and pull the screws in or out as much as you want to get the movement range that you desire. It's best to do this before you start into the Gate Titan app, because one of your first steps there will be a trigger calibration, and to do that correctly, you need to make sure your trigger is adjusted first. We'll dive into the Gate app for trigger calibration and programming a bit later on in the video. What I was finding here is that the wiring on this MOSFET stuck out too high, so I had to press it down and conform it a little more to allow the trigger to clear without it rubbing. You want to also check the sector gear sensor and sector gear teeth to make sure they're aligned well. You may be able to slightly rotate your MOSFET board to get a more optimal detection if you're noticing gear detection errors in the calibration stage. Also confirm that the sector gear rotates freely around the MOSFET in case your board's sticking out slightly from the gearbox shell. One other special thing to look for from past Gate Titan MOSFETs was that this ICS split gearbox clip used to require grinding for part of its protrusion to clear the contacts on the MOSFET board. However, with the Gate Titan 2, I found this is no longer necessary, and even if this clip were to spin right around 360 degrees, there's no contact made on the Gate Titan 2 MOSFET board, so that's pretty nice not having to worry about this anymore. I checked the clearance again with both halves of the Gate Titan installed and the gearbox closed, and as you can see, you could spin the clip right around without worrying. For comparison, here's an older ICS CXP split gearbox with a Gate Titan 1, or the original Gate Titan, installed. As you could see, I had to grind down half of the nub on the clip so that it would clear the inner contacts components of the Gate Titan 1 MOSFET. Lastly, you can install all your gears and the trigger in both halves of the MOSFET board and close everything up. I want to caution that if you're disassembling the rifle with the trigger and trigger spring, it's important to try to stabilize the trigger as you open the gearbox shell so that you can avoid it getting pushed around or scraping against the MOSFET board as you open the gearbox shell up. Usually a free thumb can do this just fine. With the gearbox closed now, you can test the trigger operation with the spring installed. You can also confirm that the sector gear spins freely. The spin is slow to start. Make sure everything's in order and nothing's rubbing or contacting where it shouldn't be on the MOSFET before moving on. With the Titan installation, you no longer need a lot of the stock internal parts. You can get rid of your cutoff lever, the trigger stop, selector plate spring, trigger trolley including spring and mounting screw, and this particular installation we also replaced the trigger so you can get rid of that. And of course the old MOSFET and wiring is removed. Flip the gearbox over and install the selector plate next. The selector plate stickers are only needed if the selector plate has a non-reflective surface on it. In my case, I have a black metal selector plate which is essentially non-reflective, so I do need to install one of the stickers. I usually just guess and check this by starting with the fully white sticker and moving into the darker black line stickers to find the best option. The MOSFET uses the reflection off of the white paper to detect which position the lead edge of the selector is in, so if you think of it that way, the edge of the white leading onto the sensors is the important part to set. With 2 sensors exposed, the gun will be in safe. With 1 sensor exposed, the gun will be in semi-auto. With all sensors covered by the selector plate, the gun will be in full auto. When you bend the motor wire connectors, be sure to bend them the correct way. If you mess this up, Gate does include spares in the box, or you can easily pick up a set. You bend them in towards the direction that the wire's crimped in on. Now we can reassemble the shell and install into the receiver. I'm going to skip the description of steps for fully installing all the internals into your gearbox. Just relube and reassemble all the internals and mount the gearbox shell into the receiver. When you grease your gears, just be sure not to put too much grease on the sector gear. Excess gear grease can cause errors in the sector gear to tooth detection, and excess grease may also fly off onto the board or cover a sensor, causing errors later. Once you've installed everything, including the buffer tube, you can check out the wire length. On the ICS Hera Arms CQR, the wire run has a dedicated channel, and it came out to be a perfect length as it was, so I didn't have to trim it. You may want to cut the wiring to suit your needs and resolder a Dean's connector on the ends. With the rifle fully assembled and motor installed, we can finally calibrate the Mosfet sensors. When you plug your battery in, you should hear some beeps. The 3 beeps here indicate that the Titan has detected a 3-cell battery, or 11.1 volt. Click on the plus button in the Gate app to start searching for devices. Select yours from the list and click Connect Now. Just make sure first that Bluetooth is on your phone and that everything is searchable. You may need to enter your PIN the first time connecting, and the PIN is printed on the box or tagged onto the Mosfet wiring. Once you're connected, just go back to the main screen and click on Titan 2 for V2 Expert to enter into the app setting. I like to start at General, as this is where you'll see your sector gear sensor status. There is no calibration required for the sector gear sensor, but the status is under General in case you need to come back here if you're having detection errors. Next, let's go to the trigger page. The first time you connect and calibrate your Titan 2, the app should automatically warn you that your trigger is not calibrated correctly. If so, just click the warning to start calibration. If not, then just check off recalibrate and it'll begin the process. Simply follow the detailed written instructions to calibrate your trigger. The app just calibrated the range of motion of your trigger, and it'll subdivide that into a ton of different trigger sensitivities. Once it's calibrated, you can tune the fire point sensitivity, the reset point, all of which give you an extremely customizable trigger pull. This in-app setting is effectively giving you even further electronic control of the same features that the trigger set screws do, being pre-travel and over-travel, in terms of when the Mosfet will actually fire and reset on. Just note that anytime you change your trigger adjustment screw, you'll have to recalibrate it. Next, go to Selector and start the selector plate calibration. The app may also warn you that your selector is not calibrated on your first time setting it up. In such a case, just click the warning to start calibration. If you're not prompted, then you gotta click those 3 dots on the top right corner to start calibration. As a caution, excess light can't be entering into the sensors, otherwise selector detention probably won't work properly. I've run into that issue a few times before in the field. The app prompts you to confirm your selector type first, and most builds will have a 3-position selector. Just follow the detailed written instructions, and use your selector to go between safe, semi, and auto to calibrate the positions. One issue I had on my first calibration was that the breakpoint between safe and semi, or semi and full auto, was too premature, meaning that while I was in semi-auto, a slight nudge of the selector caused it to detect full auto. You can fix this issue by removing the sticker if you used one, or by placing a new sticker. And try one with a thicker black line, or you can simply adjust the leading edge position of that sticker to get a better breakpoint between selections. That's pretty much it for the basic Titan 2 installation and calibration. While you may have noticed, during calibration your Titan is automatically in a no fire mode. You can enter into fire mode by selecting the little bullet icon on the top right of the screen. Do this with caution because as soon as you click it off, the rifle will now fire live as usual, even though you're in the Titan app. Finally, it's time to test fire. Hopefully this video has brought some light on how easy a Gate Titan installation can be and the ease of use and tons of features this Mosfet has. Although it's typically an expensive upgrade, in my opinion, adding a programmable Mosfet is one of the most worthy upgrades for an AEG, especially if you value customizable tuning options. There are also tons of cheap, simple basic Mosfets that help protect your trigger only.